Welcome to our tour where we're going to discover all the latest developments from AI and 5G here at the Intel booth at MWC, where we're going to show you the latest cases from 3D athlete tracking, but we're also going to show you everything what's behind the scenes, how telecom service providers can save up to 40% energy, how they can improve their VRAN and optimize the VRAN with AI, but also how they manage the data at the edge. So join me for this exciting tour and let's go to the first station. Hi Chi, how are you?
Doing well.
You have some exciting stuff over here,
That we
3D
do.
athlete tracking.
Yep.
And I always imagined, is it just a gimmick or is it really valuable for sports and maybe even beyond sports?
Yeah.
Can you explain why is this so amazing to have for athletes and even beyond athletes?
Yeah, I guess I'll start at the top. So whether this is a gimmick or not, the reason this is important, so essentially 3D athlete tracking is a software solution for markerless motion capture. So typically motion capture in the past is pretty difficult to do. It's pretty cumbersome. There's a high barrier to entry. You need to have a lab or a capture volume set up. You need to put actors or athletes in these suits with ping pong balls on them, right? All these sensors, right? This is difficult. This is hard to do. But now, thanks to Intel technologies and thanks to our AI platform, you can capture human movement. You can analyze human movement with no sensors, no markers, no suits, just ordinary cameras and AI. So yeah, this has huge implications for sports, but also for healthcare, retail equipment fitting, all these industries that you couldn't utilize this and you couldn't obtain this data for before, now you can.
And explain me how it works.
Yeah, so essentially we use AI, computer vision to detect humans in the frame. From there, we detect the key points on the body. So we're tracking about 20 key points from the head all the way down to your feet. And then from those key points, we're able to overlay a skeleton over that. And then with all that information, we're able to extract biomechanics data. So we can enable anything from a one camera device setup like we have at this demo, all the way up to a nice multi-camera broadcast setup with machine vision cameras. It's camera agnostic, it's all AI, it doesn't matter.
And yeah, you here have a simple camera. It's a good one, but it's a simple one. It's
Exactly.
under $100, so it's very easy. And I tried it myself. No preparation, no sensors, nothing. And how is it used? So is it used for scouting? Is it used for real-time analytics at sports events? Or tell me.
Yeah, so we have a bunch of use cases that it's being used for currently. You touched on one big one for us, which is scouting. So there's an application that allows people to record themselves doing soccer drills. We've partnered with a bunch of teams in the Premier League, and they're actually scouting the next generation of talent with markerless motion capture with 3D athlete tracking. And they're getting access to talent that was previously inaccessible before, right? Remote corners of the world. You would never get a scout to fly there. You would never get a scout to see you. Now you can bring yourself to the scout, essentially.
But how does that work? Because I just record somebody with my camera and they need to connect through the cloud to the platform.
Exactly. So
That's
we rely on the camera from the mobile device.
Okay.
We have our algorithms and our SDK in the cloud. All of our architecture can be hosted in the cloud as well. So we simply take that video from that mobile device, we do the processing in the cloud, and then when we're able to return that data back to the user.
And you can compare the skills and the movements with the top athletes and
Exactly.
see how closely they are to top athletes and can score them, and whether they are in places in the middle of Africa, whether they are in the city of New York. It doesn't matter. If you have somebody with a camera,
Exactly.
you can scout them
Yep.
and you can analyze it. It's Moneyball.
Right on the money.
Yeah, Moneyball, so everything is tracked and you can define already based upon real movements if somebody has the talent or not, based on data and
Exactly.
not on a scout who says, I think he's good.
Yep. It's objective data too, right? Scouting, it also relies on the fact that that person has to have the perfect game on that day.
Yeah.
If they have an off day, the scout might not realize their potential,
Correct.
and then that potential will go unrealized. Now we have objective biomechanics data, and now these players can get scored, rated, analyzed, and benchmarked ultimately against the people that they're trying to replace. So it's a pretty cool use case for scouting.
Next to scouting, other use cases.
Yeah, so if we think about human potential, right? So you could think about a coach and an athlete's relationship. A lot of the language you hear around sports is pretty vague, or not vague, I should say, but it's not recognizable to an outsider. So let's say you're a track and field athlete, you're doing a jumping movement. Your coach might say, hey, come down the runway with some more speed and then take off at a more severe launch angle.
Correct.
To someone else, we might not know what that means. The athlete might not know what that means. But if you're able to put data behind what that means, think about what they could do from there. So we find that with more precise inputs, you could get more precise outputs. And that's what motion capture without any sensor suits or markers allows for, right?
And makes the, let's say, the coaching more objective, because you can show it immediately, say, okay, this is how your movement works, this is the data, this is how you compare with what we want to achieve, with another top athlete where you want to compare with, maybe the one you need to compete with in the coming weekend.
Yep.
So you can compare everything on the spot, which makes training much more effective.
Yep.
Because you can define the target, measure it, and act according it, and see immediately if you have the results.
100%. Yeah, you're hitting the nail on the head in terms of we're taking motion capture and all this biomechanics information out of the lab and onto the field where it's actually actionable and where it can be used. So yeah.
I love these use cases. Do you have more?
Yeah, absolutely. I could go on for days. Another use case that we're very, very excited about is health. So if you think about rehabilitation, for example, let's say you're doing a crazy exercise. I don't know your sport of choice.
I had an injury 2 months ago with my skiing, and my muscle was teared apart.
Oh, yikes.
And
okay.
I recovered. You see me sporting.
Yeah, you're looking good.
Yeah, but it's still hard and painful.
Yeah, so let's say you do the surgery, you come out on the other side of the surgery. Now your surgeon, your clinician, whoever is in charge of your rehab protocol has now prescribed you a bunch of exercises, right? Typically how that procedure goes is you'd go into the clinic a couple times a week, a couple times a month. You perform some exercises, and then your clinician checks in, they view how you're doing, and then they see, okay, this person is behind schedule, on schedule, ahead of schedule, right?
If they see it, because I've done many exercises and say, oh, you have to do this exercise, and say it's not working.
Yep.
Oh yeah, but you have to do it more often, or
Yep.
they cannot really get to the point how to coach you. And
Exactly.
this really solves it.
So there's a couple different problems, right? There's rehab compliance, so the
Correct.
compliance of the movements. There's
Correct.
the data of the movements. All of this can be solved using a technology like 3D athlete tracking.
Yeah.
So imagine instead someone who, a scenario where you don't have to go into the clinic, you don't have to fake these movements. You can just open your laptop screen, your camera on your laptop screen captures the movements that have been prescribed to you. And now your doctor can see A, how are they actually complying to the rehab protocol? And then B, they have the biomechanics information. So, oh, I can see on their sit to stand movement that they're still favoring their left side over the right side. I might need to prescribe additional movements or do some things on my end to help fix that issue. So there's so many issues that can be resolved with motion capture that's now out of the lab and into the home.
Geo-independence, whether you are in the south of Spain, whether you're at the beach, whether you are close to the hospital,
Great point.
it doesn't matter.
Exactly.
And makes it much more efficient, even for the sport or every person that needs to basically get back on track.
Exactly. Yep.
And now in business, next to, let's say, sports, healthcare, is it also used in business?
Yeah, if we think about a business use case that makes us excited, it's around industrial ergonomics. So if you think about how great is it that you can order something and get it 2 days later, right?
Yeah.
That's amazing. So we have all these warehouses, we have all these factories with people that are doing a lot of manual labor to ensure that, hey, we're getting the stuff that we ordered on time, right? But you can imagine people are picking up boxes, they're lifting boxes over their head, and we don't necessarily have great ways to prevent injuries, and we don't have great ways to, prevent that from happening, and recommending and training people on proper ways to do movements in the future. So imagine a scenario where you set up cameras in your factory or your warehouse, you're capturing the movement of your employees, and then you could prevent and you could draw correlation between the way that people move and then the injuries that result from that. So you can prevent injuries, and you can also train people to do movements correctly in the first place. So there's a lot of things in that area as well that get us really, really excited.
Yeah, and even injuries, for example, with football, sometimes they get a tackle and they don't know they're injured, but on the movement you can see that they've been injured. I've seen this case already. And with the data, they know already, okay, something is wrong based upon this tackle that they had, but they don't know yet. And they can basically predict that this person is going to have a problem later on. Another one which I saw in the Netherlands, they just launched it, is with fraud detection. So in shops, in retail shops, people, if they make a movement and say, hey, they put something into their pocket, it's detecting, they get an alert. And based upon this alert, they can say, I'm sorry, can we see what's in your pocket? Because we expect that you probably have something in your pockets which you didn't pay for.
Yeah.
So once I see this, there is so many great cases.
The mind starts racing, right?
Yeah,
Think
and I think you can go on and on and on with these cases.
Yep.
So if you have a case, contact us and
Yep.
say, hey, this is a great case, because I think there's hundreds of cases here where it can help.
Exactly.
I think we can talk for hours about this.
We could indeed.
Gee, thanks a lot. I'm going to the next booth. It's great insights and I love it.
It was great talking to you. Really appreciate it.
Thank you.
Yep.
Thank you. Hi John, how are you?
Hi Ronald.
You have some exciting stuff over here.
Yeah.
Data generated at the edge. It's almost 75% of the data that's generated. If we have the data at the edge, we need to process it well to make it insightful and to make it actionable. Can you explain why it is so important for organizations now to improve their edge data collection and their edge data processing?
Absolutely. As you know, enterprises are using all this data for automation. And that's what's driving, AI at the edge is driving all this growth of edge data. And it's essential for automating and competing and offering new services. So we're gonna see this in retail. We're already seeing it with like self-checkout, but we're seeing increasingly, on the manufacturing floor. We're seeing it pretty much anywhere where there's compute, you're starting to see AI. And that's why, in fact, Intel's talking about AI everywhere. So it is definitely a trend, and it will be continuing to grow far into the foreseeable future.
And can you share some cases where they're really taking off, that are really beneficial for organizations? What are the hot use cases?
Yeah, manufacturing and retail particularly are two industries that are probably have the greatest benefit for deploying AI at the edge. And basically, so what happened in the last few years? COVID took things that were nice to have and made it business imperatives. Like for retail, just for like self-checkout, curbside pickup, things of that nature. Also, with labor shortages and supply chain constraints, that hamstrung manufacturers during COVID, made it necessary to look at new ways to automate, new ways to better predict, have more line of sight into supply chain activity. Absolutely. So all of this radically changed how businesses are approaching AI and turned something that was once nice to then a need.
Let's dive a little bit deeper into manufacturing use case. How was it done before, and what's the next level?
So as you know, manufacturers have been using robotics for quite some time now. That's not new. But however, robotic arms, those systems, those are hardwired in, very difficult to move. And then oftentimes to determine things like predictive maintenance, where when they're going to break down, it can be very difficult to address. It's labor intensive to have engineers go and to service those mechanical arms, as well as with just more labor intensive defect detection. We have there's the case with some of our automotive manufacturing partners who it could take 8 engineers thousands of hours to do a periodic spot check of all the well points for a car. Hugely labor intensive. So you put in AI here, it's a game changer.
And do they use the existing data and they connect it to the existing machines, or do they need to add additional sensors?
Right. So industry has taken both approaches, where there have been solutions to add smart cameras to look after the machines, and then that would run on AI. But we're actually able to use time series data to avoid some of that unnecessary additional layers of technology. So you can use time series data in an edge context and use that for predictive maintenance.
Yeah, and detect the anomalies in real time.
Yeah, you're seeing servos you're not getting the same response time, so you have all that sort of that observability into the functioning of the factory floor.
I know you recently launched a new platform. What's different from how it was before? Because all these companies have their existing hardware, their existing data systems, maybe they have their proprietary systems. How can it work within all these different environments?
Yeah. So as you know, compared to cloud, the edge is a relatively nascent space. It is a growing market, but right now it's really dominated by very bespoke vertical solutions that will address whatever use cases are specified up front. But when it comes to adding new use cases, if you want to add another smart camera use case somewhere, you basically have to redevelop that whole stack, refactor. It can be extraordinarily expensive. Also, there is perception that to do inferencing at the edge requires high-powered specialty hardware.
Correct.
Which is also, it's backlogged and it's costly, both in terms of just purchasing as well as, total cost of ownership. So there are some of these constraints, both in terms of hardware, but also with software. The the edge isn't the cloud. It is not, homogeneous architecture surrounded by, the physical, what ensconced in the physical security of a data center. It's exposed. It's different form factors. So it's a very different architectures, and it has to work within within your existing your legacy the network. So it's a really complicated thing to pull off. And so our what we've just launched to help is Intel's new Edge platform, and that allows enterprises to build, deploy, run, and manage AI edge applications with cloud-like simplicity. And in effect, it's a cloud for the edge.
And inferencing at the edge is one of the top priorities for telecom service providers to monetize this new type of service. Is there a connection between the potential to monetize it by a telecom service provider and this platform?
Oh, absolutely. We have some. We do have some telcos who are using it right now. So absolutely, yeah. Any AI use case that you can think of can be supported through the platform. So just with private networks, what is most keenly of interest is, from an infrastructure perspective, is the ability to have zero-touch provisioning, which is basically being able to manage an entire fleet of devices through a single pane of glass and do so securely. And that's of huge interest to enterprise and our telco customers.
I'm excited to come back next year at MWC and see what kind of new use cases you have deployed.
Thank you, Ronald.
Thanks, John. Thanks. I'm going to the next booth and see you next time.
Great. See you then.
Hi, Steve. How are you?
Good. How are you doing?
Some exciting times here at MWC.
Absolutely.
Yeah. So you have 5G core networks, but it's mainly about sustainability and energy reduction.
Correct.
Can you explain why is it so important for telecom service providers? It's most, I think, an obvious question, but I really want to understand this energy part. How much is this from their spend? How much from their cost? Why is this so important?
Yeah, that's a good question. Telco industry in general is just really focused on sustainability, right? So from an Intel side, we're focused on manufacturing, right, from a sustainability standpoint, so reducing our carbon footprint in manufacturing. And then we also have to focus on how we design our products to be more power efficient, right? Now what we're showing here is we're focusing really on, okay, the servers have been deployed, they're in the networks, they're in the data centers. How do we reduce runtime power while these servers are actually operating on the networks?
Yeah, because power is a big part of their spend.
Yeah.
How does it work?
Yeah, so it's actually pretty simple. So power management capabilities have existed on these CPUs for quite some time. Unfortunately, since performance is such the preferable KPI and we don't want to have any impact on performance, operators typically tend to turn off power management capabilities, right? So we aim to change that, and we developed a piece of software called Infrastructure Power Manager. And what it does is it monitors the workloads that are on the CPU. Right? So example here, we have a 4th gen CPU. It has 32 cores on the CPU. We actually look at each core individually. We say, are you busy? Are you busy? Are you busy? In a tight loop, like every 3 milliseconds. And by analyzing that data, we can say, we have room to actually reduce the CPU frequency of every single core individually, right? And it's all based on the fact that networks are typically cyclical in nature, right? No networks are just on 100% all the time.
Goes like this,
right?
Yeah.
Goes like this, people are sleeping at 2 a.m., right? So no need to have the servers on full speed all the time.
Correct.
So in those times of reduced demands on the CPUs is when we have the opportunity to say, all right, we're going to bring down the voltage and frequencies of those CPUs. Over a 24-hour period, it starts to add up. You start to see some massive savings in that time.
Yeah, so it's pure optimization from the existing infrastructure on Intel compute.
Exactly.
And that can save 40%?
Yeah, so we partnered with Nokia, who's been a great partner with this. They actually took our Infrastructure Power Manager software, put it next to their network functions. We're showing 2 here. One's the AMF, which is typical in 5G core. UPF is a very sensitive workload as well. And they're able to show using this with their traffic profile on how they would typically deploy this, they're seeing 40% savings over 24 hours.
Yeah, and with the sustainability goals, this is a no-brainer.
Yeah, you start multiplying this by thousands and thousands of servers in the data center, right? And huge impact on your OpEx. Absolutely.
I love it. Thanks, Steve.
Yeah, absolutely.
Thanks. I'm going to the next one.
Okay.
Thanks. Hi, Kevin. How are you?
Very nice to meet you. This is Kevin.
Yeah, we're at MWC. We have some exciting developments over here, especially for the telecom service providers.
Yes.
AI for VRAN.
Yes, exciting.
Many different type of use cases. Can you explain why VRAN, and especially AI for VRAN, is so important for the telecom service providers?
Absolutely. I'm happy to introduce that. AI in the RAN give a lot of benefit to the operators. It's about the energy saving. It's about network optimization. It's about the service guarantee for the operator can generate new revenue opportunities. So a lot of opportunity need to be unlocked. And today in this demo booth, we're gonna show the 3 use cases that we collaborate with our global operators.
Let's do it.
Yes, sure.
What's the first one?
So I'm going to show the 3 demo.
Okay.
The first one is about the power saving,
Okay.
energy saving with AT&T.
Okay.
The second use case is about the user level beam management, working with Deutsche Telekom. It's
Okay.
about user channel quality.
Okay.
Third one is about network slice radio resource management.
Okay.
Working with Vodafone is about guarantee the service requirement, such as a cloud gaming. So
Okay.
I can show one by one.
Let's go ahead.
Sure. So if you see here the screen, we have an AI technology that decide the CPU frequency. You can imagine your car move fast, move slow. That will impact on your fuel efficiency. Likewise, we have a CPU processor having power control technologies, and we evaluate this AI technology to decide the right CPU frequency in a way to maximize power saving, but no impact on the RAN service. So if you see here, you can see the CPU frequency moving dynamically. But you can also see here a lot of RAN-related metrics, such as the traffic volume or the PRB, so physical resource block radio utilization. You can see the RAN delay happen. So AI monitor multiple metrics from the RAN and make the right decision. For example, if you see here, traffic volumes goes down, CPU dropped quickly. But it immediately goes up because it monitor RAN delay is increased. So it immediately return back to the high CPU frequency, you know. So we work with AT&T by having 24 hours, a 5G data trace, and then apply this AI. And then we see here is about the 17, for the 24 hours, it's about 16 power saving. This is a real-time measurement. You can see the saving is changing. So we were able to show the 16% power saving. And then
Which is substantial because
substantial, yeah.
energy is one of the biggest costs for
Exactly.
the telecom service providers.
I fully agree with you.
Okay, let's go to the next one.
Sure. The next one is for the beam management. You can see here the base station, and here are the users, mobile users. Sometimes they close the cell center. Sometimes they move to the edge. So when users close to the base station, everything okay. Radio signal is very strong, but we don't need to worry about it. But users moving to the edge, base station really think about how I can make very, very directive beam to that users based on user's location and based on user's radio channel quality. This is complex problem to be solved in the base station. So we work with Deutsche Telekom having AI technology, see how we can improve more, put those kind of users beam management so they move to the edge side, they can still keep the high channel quality. So I'll show you something. Here, the green color is AI-based beam management. Yellow color is their existing baseline. And green color, here is the throughput, and here is the delay. You can see some of the RAN-specific metric. And here is MCS mean is modulation and coding scheme. It shows a kind of user's channel quality. So higher is better. So at the beginning, when users close to the cell center, you see, looks everything similar. Whether AI, non-AI, nothing different, nothing different. By the way, this is real-time capturing.
Okay.
But once they move to the edge, let me a little bit move the video to the right side. You can see the difference starting happening.
So
yeah, they are
we're
moving.
monitoring the
Yeah.
orange person, yeah.
They're moving to the edge. You see this kind of 10x difference. This is 5 users aggregated throughput. It's more than 100 megabps versus here is the 10 megabps. And you see now the channel quality indicator is almost close to 1 versus AI-based keep the high channel quality.
And if there's no reception, experience is bad, people are dissatisfied, and they start complaining. Whatever the reason is, they don't care.
Exactly. So we try to address the problem, especially for the edge situation, how we can improve more the channel quality.
Perfect. Last case.
Okay, the last one. Last one is about the guaranteed service. For example, here is the cloud gaming. You can see the left-hand side is manual-based radio resource allocation, and right-hand side is AI-based real-time dynamic allocation of the radio resource. And cloud gaming, Vodafone case, they gave us kind of target performance SLA. For example, like throughput should be like 20 megabps. And delay is very important when the cloud gaming. Delay is supposed to be less than 5 milliseconds. So you can see here the throughput. You can see here the delay. This is manual based. This is AI based. Now I'll show you one thing. So the users start the cloud gaming and everything looks okay because there is no traffic congestion happen. But now the traffic congestion happen, and you will see soon that left-hand side of cloud gaming is going to be the quality drop happen, video stalled, and the latency is going to be increased. Let's wait just a few seconds. Now you see the latency is more than 139 millisecond video stop. And then base station quickly allocate more resource, more ready resource.
Yeah.
You see the 40%. So it recovered. But if you see the AI base in the right-hand side, it kept the about 3.6 millisecond all the video game time, and then there's no such large allocation of the ready resources. It is real-time based, efficient way of
from where there's the demand. That's important. If there's demand, it's optimizing it. If there's no demand, it's downscaling it.
Right.
Perfect.
If you just reserve the resource for this kind of cloud gaming users, you may end up like wasting of your resource, because even there is no cloud gaming users, you may reserve it like there is no car, but you make a couple lane, right? So that's how the AI, think more efficient way, more intelligent way to allocate the ready resource, by understanding all this.
Deliver better experiences, but also reduce the cost from power energy. Perfect. Thank you, Kevin.
Thank you so much.
Thanks.
It was nice meeting with you.
Nice meeting you, and I'm going to the next station.
Sure.
Thanks.
You.
Thank you.
Have a good one. Thank you. Bye-bye.
What an exciting tour this was. I really love the use cases from the 3D athlete tracking, where it could help scouting, where it could help with athlete performance, where it could help with many different healthcare cases. The cases were basically endless. We showed you differences like how to manage AI, manage your data, manage your performance at the edge with the help of AI. Also to mention how to save 40% of energy by the telecom service providers and how to use AI for VRAN. I hope you enjoyed this tour as much as I did, and I really want to thank you for joining us today, and we look forward to seeing you next time here at Intelligent World. Thanks, bye-bye.